Morning. It's Thursday morning at 9:10 a.m. Illinois Central College. We're starting Lab 4, measuring voltages with references. This is ElectS 131, 132. Present with me are Tegan, Kyle, Harrison, M-Daddy, Paul, Peter, Gavin, Summer, and Caden. It's been established that nobody needs a Band-Aid and that the instructor is a little bit of a jerk. Okay, let's look at what we got here. Read the intro. Voltages do not have polarity unless connected to a reference point. One voltage may be more or less positive than another point, but there is no polarity unless there is a reference point to separate positive and negative voltages. Did you guys discuss this in class yesterday? No? Is there any confusion on it? Well, if there is, let's clear it up today with the lab. Oh, wait. Forgot to ask. Anybody get arrested last night? No? One of these days, I'm going to get you. Can you all see my screen? I want to teach you a little trick that might be handy for you over the next semesters. You ever heard of alt codes? Watch this. See where my cursor is? If I press alt, hold it down while I go 2, 3, 4, and then let go of alt. Ooh. Alt 2, 3, 4. Remember that one. So I rounded my numbers up to the nearest decimal, or nearest whole value, no decimals. It's weird, all of my resistor values ended up less than the nominal value, but whatever. Let's see. I'm guessing that in the circuit I should get 4,300 ohms. If I add all those up, I'm going to get less than that, but let's see what I get. Just be aware that they kind of trick you a little bit in this schematic. They got R1 is the 1500K ohm resistor. R2 is the 1K and R3 is the 1.8. So I've got that set up on my deal here. I'm going to put my camera on. Whoop. Are you guys, so when I do that, do you guys have the little window that shows my proto board here on your screen? Can you expand that to make it bigger, or would it be easier for you if I unshared and just had the big shot of my proto board? If I click what? Oh, you can do that? So I know I can take my proto board and expand it so it's bigger, but Matthew's saying that you can pin my video. I guess however you want to do it. If you want me to take it off of the lab and just put my camera up there, then let me know. But the point I'm trying to make right now is that this is the 1.5K ohm, brown, green, red. This is 1K, brown, black, red, and this is 1.8, brown, gray, red. And then to measure total resistance, I'm just going to go like this. Come on. Come on. Bloop. I'm getting 4250. What's the alt code? 234. Procedure, did number 1, did number 2, construct the circuit. I guess I gotta put a 20-volt source on there. And D, we're gonna reference that to ground. So I guess for this lab, we're gonna need another lead. A, see where our ground is in our power supply? Yes, no, maybe? How do we want to do that? Let's see if we got any green leads in here. Actually, take an alligator. Measure it. Measures, I see about 1500. Sometimes my pictures on me looks like brown, green, red. Looks like brown, black, red because it's a little dark on mine. Yeah. Okay. All right. So here's my plan. Green banana jack into the green power supply. This side. Oh, I can't do it. So I should be able to get this, hopefully, green guy plugged in there. No, maybe. Or do that. You pull your alligator clip out of the boot. Just bloop. Okay. And then your green maybe cannot go in there. With French toast. Oh, this is for the. Oh, I see now. I see now. All right. Never mind. Y'all should have one of these types of leads. Do you see me? So this is one end, black, it's got a little gray thing on it. Yeah, yes, no? Plug your alligator clip into that. See, this one has a little insert, so it's supposed to fit over the point of your meter lead. So we'll use this for the ground instead. As long as we can get this in. No, we cannot. It ain't gonna work. Forget what I just told you. This is supposed to go into the multimeter. That sucks. What I need are a bunch of these. I don't know how to get that little insert out of there. We used to have a bunch of these alligator clips, but I don't know where they be. Oh, got two. And four more, we'd be in good shape. Your meter what? Where'd you get those? Not metered. Okay, not metered. Oh, okay. Somebody can use that, yeah. Somebody can use that for sure. So, are you do too? You guys all get those? Yeah, Kevin's got one. You have two of them or one? I just got one. Okay. We're gonna take whatever alligator you clip you have, put them in your one that I gave you. So I need to find two more. What the? Yeah, wire nothing. Yeah. Not gonna work again too.
Good. Paul? Paul, yeah, I'm fine.
Crisis averted. Okay, so what are we doing? Oh, green. 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 Now we have reference to ground. Hey, who's updating normal text to match? Somebody took over my screen. Oh, that's me. This is my little drawing pad thing. Okay, hook up to 20 volts. Using Ohm's law, calculate the voltage across each resistor and record this value on the left side of table 2. So what do we think VR1 is going to be? Remember how we did this? Yes, no, maybe? So here's my circuit. This is 20 volts, correct?
Yeah.
So that'd be E total. I total, we're trying to figure out. Do we know R total? We measured it, right? So mine is 4250. Alt 234. So what would our total current be? What's this called? Ohm's law. If you guys don't say Ohm's law at least once in every one of these labs, I'm gonna puke. Just kidding. Ohm's law. So my total current is gonna be 20 divided by 4250 equals 0.005 amps, or 4.706. So, at each one of these resistors, how much current's going to be flowing through them? The same amount of current because it's a series circuit, right? So if this is R1, and that's what, 1500 ohms, but my measured value is, wait a minute, that's R2. Yeah. Either way, set it up however you got it in the circuit. So mine is going to be 1481 ohms, 0.0047 amps. I should be able to figure out the voltage drop across there. So I'll put it like E sub D, voltage drop. And then this is going to be R2, that's my 1000 ohm, which I got 989. And 0.0047 amps. And this one's going to be R3, 1782 ohms, 0.0047 amps. Voltage drop should be. So what's Ohm's law as far as finding the voltage of these? E equals I times R. So I need to multiply those two for each resistor, and I should find the voltage drop across there. So for R1, should get 6.97 volts. R2, I should get 99 times. Everybody follow what I'm doing, or do we have questions? I feel like I'm talking to myself. Everybody good? All right. So the voltage drop at my last resistor will be 1782 times 0.0047. And you know your numbers are going to be different than mine, right? Because our resistor values are just a little bit different. 8.38. And what do you think would happen if, what do you think would happen if I added all three of these voltage drops up? Right, should equal how many? 20? Should we do that because we're having fun? So it'd be 6.97 plus 4.65 plus 8.38. Holy shit, look at that. 20 volts. I need to find some tape to put around my lead so you can see which one's my problem. You would think that in an establishment such as ours, we would have electrical tape, right? You would hope so.
White. We don't want white. We need this awesome orange duct tape. When you see orange duct tape on my leads, that's the power supply. Okay.
20 volts. Volts. Cool. All right. So then, how do I measure voltage across the resistor? Pretty easy, right? So for R1, got my meter set to DC voltage. For R1, I'm just going to read across R1. I'm guessing I'm going to get 6.97 volts. I'm getting exactly 6.97 volts. Isn't that so freaking cool? Are you guys excited about this as I am? Yeah, I can tell. So number 5 is talking about voltage drop. Okay. Anybody tackled number 5 yet? No. Okay. Well, let me show you something. When I put my red lead here and my black lead here, I, for mine, got plus 6.97 volts for this one. What does that mean as far as current flow and polarity? What if it had said negative 6.97 volts with my leads like that? What's the difference? Since it said positive, it matched up with how my leads were. If I switched my leads around, it would have said negative, right? Because I'm on the plus side over here, and I'm on the minus side over here. So current in this case, since these match up, current is flowing in this direction in my circuit. And that's important because if I wanted to know what the voltage was at point B, well, let's start with A. With respect to ground or negative, so my leads now are gonna be, my leads are gonna be, so I'm at point A. So here's 1 meter lead. And I'm just gonna take it to the negative side. So here's my other meter lead. What should my voltage be right here? At point A. Plus 20. I'm just reading the power supply. What should my voltage at point B be? So I'm going to leave the black lead down here, and I'm going to put my red lead at point B. What would this voltage be? Yeah, there's voltage drop, okay? So remember this, because we're in a series circuit, R1 is going to eat up some voltage. And it's going to be distributed evenly, or depending on the resistor's value, amongst all the resistors. So because this has a voltage drop of 6.97 volts, I could expect to read at point B 13.03 volts. Right? And then what's my voltage drop? My voltage drop at R2 is 4.65 volts. And my voltage drop at R3 is 8.38 volts. So at point C, what could I expect to read? All right, it'd be 13.03 minus this one, minus this voltage drop. So at point B, I'm at 13.03 volts. With respect to this, right? It's always, this is the reference part of it. With respect to this minus side right here, I would read what, 8 point, whatever that is, 8.38. And it's interesting because the last drop I need to do needs to get back down to 0, right? So at point D, I should read 0 volts. So in order to read these, I would just take my negative and put it with the negative of power supply. So what I'm saying is I'm going to read with respect to this. This is my reference. So if this is my reference with respect to that, at this point, I should get 0. At this point, I should get 8.38. I do. At this point, I should get 13.03, and I do. So that's how we're going to fill out that table for question 5 and 6. I know you guys wanted to hear some Brandy this morning. A lot of you guys aren't even old enough to remember Brandy. She was kind of a big deal in the 90s. Maybe you were born in the 90s, 2000s, 80s. Me and Paul are the only ones who know who Brandy is. Does it bother you? I keep calling you Paul.
Yeah.
All right,
Think
good.
about changing my Skype name now.
Okay. Anybody to question? Seven yet? Do you understand what it's asking you to do? All right. I'm gonna do it on here. This is where our sweet frickin' thing comes into play. All right, so let's look at my power supply. Now I'm gonna start reading voltage. Now it's asking me to read it with a different reference point than I had before. We haven't even used our ground yet, but this is where this comes into play. We're gonna ground one part of this circuit, and what I have is how mine is set up here is, let's see, this is plus 20, and then I'm going to R1, and then I'm going across here to R2 and R3. And this is and according to the schematic, this is A, B, C, D. Making sense? So before, when we were checking all these voltages, we were checking with respect to ground in this case, which we didn't even hook it up, but it doesn't matter, but it's the same potential. But we were putting black here and red here was plus 20, and then minus that voltage drop, and then minus that voltage drop down to 0. Now it's going to have us take and move the ground to point, what is it, on question 7, point C. So now we're going to take, this is the symbol for ground, by the way. It's on your schematic. But this means ground. And we're going to read voltage with the negative side of our meter at this point. Okay. What do you think that's going to do to these values? Any ideas? The values are going to be the same, but the polarities are going to change, right? Because current in this is, the way I have it drawn up, is flowing from left to right on my circuit. So here's current, right? So if I read with my positive lead here and my negative lead here, I should get a positive voltage. But if I keep my negative lead and then come over here, now I'm going to get a negative reading on my meter because it's flowing in the opposite direction than how current's flowing in the opposite direction than I have these bad boys, right? So this is where the reference comes into play, and that's where we're going to play around with these numbers. And now it's just a matter of hooking it up how they want you to in each question, taking the readings and seeing how they match up, right? So on my circuit, how I'm going to do this is you should all have a green doodad somehow going into the ground of your power supply, right? And I've got it hooked up in this hole. So point C for me is right here. Okay, so that's my point C. Now I can also, when I'm reading voltages, grab onto this with my negative. Right? So now my reference point is this point C. I hope that's making sense. Is it? Good. Okay, so same circuit, same setup. I'm just moving the reference of where I'm reading voltage. Now, if I read voltage at this point, I'm going to get a negative 8.38 volts. And if I read it at this point, I'm going to get a positive, whatever that one is, 4 point something, positive 4.7. Make sense? So all of those alligator clips and the green leads and everything, just keep that stuff at your station. We're the only class using this lab this semester, so just hang on to that stuff in case we need it again. The rest of the lab is just going through and measuring those with the different reference points. And just turn it in whenever you're done. 3 questions at the end, not too bad. Do you have the time to listen to me whine all at once? I am one of those melodramatic fools, neurotic to the bone, no doubt about it. It's not hard to concentrate when I'm doing this, is it? Sometimes I give myself the creeps. Sometimes my mind plays tricks on me. You guys can join in anytime. It all keeps adding up. Let's make the other class jealous. Yeah, let's make the other class jealous. You ready? You guys know the words? You need me to put them on screen. I went to a shrink to analyze my think. Oh yeah, I'm recording. I better stop that.
Well, you can now download his music.
Yeah. I'll give you an autograph before you leave. I'm going to be a YouTube star now. Sometimes my mind plays tricks on me.